Yeah, so hello everyone, and I'm Shivay, and I'm more than happy to take over session with DSC and DSC GTBIT for the Hacktober Fest. So first of all, a big congratulations to the entire team for having put up such an amazing 1.5 day session so far with an introduction to GitHub and a few exercises on Flutter and crowdsource. So I'm more than honored to be presenting today on topic of introduction to TensorFlow and TensorFlow.js. Now, just to give a brief background on what's the importance of this particular topic and how and what all things are we going to be covering in this particular speaker session. So the first thing that we'll get started is by introducing the concepts of machine learning in web development, and also then talking about what exactly is TensorFlow, how you can leverage the use of TensorFlow.js in your web applications, and why it is relevant to this topic of open source and Hacktoberfest. So just to give you a brief idea about TensorFlow and TensorFlow.js, both of these are completely open source libraries that have been made specifically for machine learning applications by Google. And since we are also celebrating open source with Hacktoberfest, we are embracing the use of open source technologies. So, specifically when it comes to machine learning, TensorFlow is probably the biggest library or the biggest name or the most prevalent industry standard when it comes to open source machine learning libraries. So today we'll be going over what exactly is TensorFlow, and we'll also take up a small project on TensorFlow.js. So the majority of the application or the majority of the slides that you're going to be seeing are going to be dedicated towards TensorFlow.js, because that is definitely a much more easier way of entering into machine learning rather than just going with TensorFlow. So yes, so do expect to see some cool demos, and it's going to be a fun. I hope that the entire presentation is learning experience for everyone. And in the last, I'll be more than happy to take up some of your questions. So keep adding your questions in the comments section. Right. So let's get started. So this brief background about myself. I'm Shivay, and currently I'm working as a TensorFlow JS community working group member and an SIG member. So representing the TensorFlow.js community around the world, specifically from the APAC region. And I'm currently a lead engineer at Dark Horse, which is a football analytics startup. I was a Tools of Code mentor with Jenkins and CNCF, and a Will Code mentor at TensorFlow. So that's briefly about myself, and then first we'll discuss on what exactly is machine learning, because since we'll be covering on TensorFlow and TensorFlow.js, just sort of giving a brief recap or a brief introduction about what exactly is machine learning. So machine learning is a way in which a computer system or a machine or some kind of a program that you're running is able to understand patterns, or let's say it's able to understand the context of a particular problem. You don't need to give it some kind of a operation and tell it that it has to perform this operation. So let's take the example of a conventional application where you're running a calculator based application. So you tell the computer that these are your inputs and this is your operator. So let's say you're adding two numbers. Over there, the operator already defines how to use that particular operator. So in this scenario, it's an addition operator, and the program will give you an output. But in the case of machine learning, the machine itself or the program is able to decipher through the concept of the input and the output. It is able to decipher what is the process that is going on behind the scenes by looking at the various patterns, by looking at different observations from the data that is provided to it. So in this scenario, in a machine learning use case, the output would be given. So let's say you give the output as 8 and you give the numbers as 5 and 3. The machine learning is able to predict that the operator that is being used over here is an addition operator. So when it comes to machine learning, what the exact gist is that machine learning is able to find patterns and observations from a given data set that you're providing to it, and then based on those data sets, it can provide you cases of then providing you further predictions. So let's say it's able to decipher, okay, this is the operation that takes place. Now you can give it more and more input, and it will predict outputs based on that operation that it has predicted. So that is machine learning, and web development doesn't need a lot of introduction. But basically, web development is all the different kind of websites, web applications that you see on the internet, on the Play stores. Everything is leveraging web development. And just to give a brief sort of overview, normally you would have two different scenarios. One is the client side. The client side is the one where you interact with the browser or the application itself, and the server side is the one where all the kind of operation or logical operations or database related operations. Let's say if you're having a sign up sign in flow, you're having something that is updating on the server. So let's say live cricket scores are getting updated after every second, and those get displayed onto the website. So all of those background tasks that take place are happening on the server side. And now the most important question that arises is, what is the need of machine learning in web development? So web development as in itself is a quite large field, and the most commonly used language in web development is JavaScript. Now, for a lot of those people who are creative artists, who are designers, web designers, website developers, they are sort of only exposed to the realms of HTML, CSS, JavaScript, or other frameworks of JavaScript. And normally they don't have a lot of experience with Python or machine learning, because Python and machine learning, and specifically machine learning, does require a deep knowledge of mathematics, statistics, and that in itself can take a lot of time. And a lot of time, what happens is that these people are coming in from non-technical, or let's say non-CS backgrounds, and they are making these websites. So the need for machine learning in web development arises from two main reasons. The first one is that machine learning today is finding itself being used in almost every field possible. So machine learning is also quite prevalent in web development already. So let's say you're visiting sites like YouTube, Netflix, you're visiting Amazon. So see all of these different kind of recommendations that you get on these platforms. So those are using machine learning to see what is your use case of on those particular applications, and then providing you user customized or more relevant feed to you. Or let's say that if you put up some kind of a hate post or some kind of a post that is not in guidelines with Twitter, so Twitter can automatically detect those kind of posts or tweets. So there are multiple applications for web development that are all for machine learning in web development that are already there. But and now the need is to sort of expand it even further, so that the machine learning can become more and more accessible to people who might not be having experience with machine learning and who are into web development. And that is where the concepts like TensorFlow.js come into the picture, which will be taken up a bit later. But this should sort of give you the main scenario why machine learning is in a real need in web development, because again, it's finding use in almost each and every different field possible. And now it's also time that we make it easier for having machine learning based applications within web development, and make it as much easier to implement it as compared to earlier standards, because earlier it used to be very difficult. Now coming on to the next topic, that is introduction to TensorFlow. Now just to give you a brief idea on what exactly is TensorFlow. So TensorFlow, as I've already said, is the biggest open source library that is being used for machine learning. So it is a library that was made by Google, and it's completely open sourced and completely free. And internally, Google uses it for a lot of different research projects. But as a tool, the main the so the heart of how it really got started was to basically be able to do a lot of different mathematical operations on very large vectors, on very large matrices, or on very large mathematical computation. But as in more people started using TensorFlow, they found its application in various other fields, not just in pure research and mathematics, but also finding a use in a lot of different other applications. And it became the most popular machine learning library that is being used. And if you have heard about neural networks or deep learning, TensorFlow is the go-to library that you can use. So it helps, as I've already said, that it was made for developing or running large computations on very large number of data sets, and those included data in the form of multi-dimensional arrays and vectors, which are called tensors. So how this word TensorFlow sort of breaks down is that tensor that you see is those higher dimensional arrays that can have multiple different dimensions, and though these can get quite complex as well. And how are the data being flowed from these tensors across various other tensors or various other parameters that might be there in a TensorFlow based network or a TensorFlow based machine learning model. So it basically uses the concept of data flow graphs that have various nodes and edges. So how your input data that you might be having, how is that acting and how it is flowing from one node to another? Because if I show you like how does the TensorFlow based neural network look like? So basically neural network is nothing but it is sort of been inspired from how our brain networks, so how our brain neurons work, where each neuron is connected to another and there is a flow of information. Similarly, in a neural network, there is flow of information from an input node to the output nodes, and basically sort of all that kind of decision on how that flow should work. That is where the TensorFlow comes into the picture. So all the different kind of computations that are happening, those are the tensors, and the way the information is flowing back and forth between different nodes, that is where the data flow graphs come into the picture, and that is where the flow part of the TensorFlow comes into the picture. So that should give you a brief idea on what exactly is a TensorFlow. Now coming on to the main part of it, which is TensorFlow.js. So as I've already given an introduction about TensorFlow, so TensorFlow in itself is an open source library that has been written in C++, and it has got great support both for C++ and Python. But we wanted to run the TensorFlow based models in the web browser, and giving it access or giving it the kind of let's say an opportunity to use it with JavaScript, or let's say in the web browsers or in web development. So there was a special library that was created specifically for JavaScript by the name of TensorFlow.js that provides you the C++ and Python bindings of TensorFlow basically to the web development as well. And this is how you can now use the TensorFlow based machine learning models or bring in more applications of TensorFlow to the browser by the power of JavaScript. So as I've already covered that for a lot of different web developers who have been using JavaScript as their main language for years, it can be very difficult to switch to a language like Python, or it can be very difficult for them to sort of understand the concepts or the true concepts of machine learning. So, in order to make it more accessible and more easily understandable for the web developers or people who are using JavaScript, that is the reason why this new library, and again it's a free and open source library created by Google by the name of TensorFlow.js was introduced. Now this slide sort of covers on the extent of machine learning that you can use with JavaScript. Now, JavaScript is again a very powerful language that can be used to be create browser-based applications, server-based applications, desktop applications. You can create mobile applications. You can create IoT-based enabled applications by using JavaScript. So, by providing the kind of by providing the support for machine learning with JavaScript, you can now access these machine learning models on all of these different kind of platforms like as I've already said, having support on the browser, having it gets supported on server, on desktop, mobile, IoT, and this sort of gives you an example on the kind of extent that we are looking at. So, for example, on a browser support, you can get support on various different kinds of browsers like Chrome, Safari, Mozilla, Opera, and then you have JavaScript also running on the server side. One of the most popular server-based language being Node.js or Dino. And then you have mobile-based applications with React Native, which is an hybrid development platform where you can create hybrid applications for Android, for iOS using React Native, and then you can use Electron.js for creating desktop-based applications, and you can put up a Node.js server with a Raspberry Pi to create IoT-based applications. So, by looking at the extent in which JavaScript is being used, and given that how versatile the entire support for JavaScript is, you can use machine learning models in any of these different services, and that makes it so versatile and easy to use. Now, there are essentially three different types of use cases that are provided while you're running these particular machine learning models on the web browser. So, TensorFlow.js has provided you three different ways of using machine learning models with your applications, with your web development applications or web applications. And the first one that I want to talk about is running existing models. So this is probably the most easiest way of getting started with machine learning with your web applications. So TensorFlow.js has provided us with more than so let me also quickly share the screen. Just a minute. Yes. So TensorFlow, as I already said, that TensorFlow.js has provided you multiple different existing models that can be directly used to train the machine learning models, and those already trained machine learning models can directly be used and embedded within your web application that is created. And then the other way of doing it is that it has provided you the the option to actually retrain the existing models. So it provides you the option to also use some of the existing models, and instead of using them directly, it allows you to provide your own data set so that these machine learning models can adapt to your data set, and they can provide you much more customized and much more optimized results. And you can write your own models completely from scratch and train them from scratch by writing these models in TensorFlow in JavaScript itself without having any sort of knowledge about Python, and then deploy these particular models in JavaScript and use them with your web applications. So this makes it very easy and versatile to actually use these applications, or use different kinds of machine learning models with your web-based applications. Now, coming on to the next part, where I talked about the first part, was that you can actually run existing models that have been pre-created and directly just use their functions or their outputs for creating simple machine learning based applications on your browser. Now, as I already said, that JavaScript itself, since it's so versatile, you can create applications like augmented reality. You can create virtual reality based applications, sound recognition, gesture based interactions. You can create chatbots. You can do sentiment analysis, and you can even optimize your web pages by using the concept of machine learning. And now, coming on to the already existing models that are created. So I've already said that there are a lot of different models that you would find pertaining to image classification, object detection, body segmentation, pose estimation, finding out how toxic is a particular text, doing things like speech commands, running some of the more popular machine learning based models like the KNN classifier, which is again a very popular algorithm within machine learning. So it provides you easy to use models that can be directly imported within your project, and to sort of give you an idea, so we can put in a tensor TFJS models GitHub. So if this should actually show you the repository. So this is the open source repository that is being hosted on GitHub. Again, you can find the entire code base for TensorFlow and TensorFlow.js on GitHub under the github.com/TensorFlow. And over here, you can see all the different kind of machine learning models that have been created, predefined models. So let's say if I want to look at hand pose, that can detect all the different kind of edges of your hand and whatever sort of angles, or let's say the different kind of fingers that you have, it can detect all of them individually, and what if hand action that you perform, it is able to understand that and it can use. So it provides you very simple to use a documentation that you can definitely just start using this particular functions. For example, let's say if you're using hand pose, you just require the model directly and then start using these predictions that, and you don't even need to write any machine learning based code. You just have to input whatever particular activity or whatever function that your particular web application has to perform, and you simply just have to load the model and start using it with your project. So it is that simple to start using machine learning models without having any prerequisite knowledge of machine learning in general. So that is about TensorFlow.js pre-built models that have been created. And now coming on to the next type, and again, these show you some of the examples. So Coco SSD is a very popular object detection model that now has been converted into a TensorFlow.js binding as well, and it has been trained over 90 different classes. And as you can see from the example, that it is able to predict or it is able to detect the objects with a very high accuracy rate as well. And now coming on to the next part, that is transfer learning. So what does transfer learning mean? So basically transfer learning means that you use your own data to basically enhance or retrain some of the existing models that have been created beforehand to make it more optimized for your own kind of workflow that you have created. So an example of this could be that, let's say you have a very basic neural network that has been trained for detecting the different kind of letters or different kind of numbers, and you give it your own data that has, let's say, different types of handwriting styles, and now you're training it to fine tune this object or this alphabet or this number detection model, and you train it with your own data and it adapts to your existing data, and then you can use this model directly for your application. Now uh, basically, um, TensorFlow has provided, or Google has provided, a very useful tool to actually sort of simulate this transfer learning. And that tool is something that I'll very soon actually show you, so that even you can work with it. So it's a very popular tool by the name. So I'll quickly just show you. So basically, what we can do is that, so as you can see over here, how the TensorFlow neural networks work in the background. This should actually give you the this scenario. So let's say I have an input data set that has a lot of different features. So and how, as I have already said, that how neural net works is that a neural network will have a bunch of different input data sets, and it will be able to provide you some kind of a output. Now it can have multiple outputs or it can have a single output, and in between there are a lot of different hidden layers. So basically the flow of the information starts from one of these input layers that you have. It basically goes through all the different kind of hidden layers, and based on the energy that is carrying, so there's a concept by the name of activation energy that lets you basically decide what path that particular information flow will actually take place based on the activation energy that is being created. So this shows you a very sort of an overview example of how these TensorFlow based neural networks perform in the browser. Now again, for someone who might not be having a lot of knowledge about these concepts, can be very it can be sort of intimidating at first to be able to understand, okay, what does learning rate, what is activation, what is regularization, all of these different tools means. So for to sort of circumvent that, Google has provided tools that you can actually just use on the browser itself to sort of simulate. And what happens is that these neural networks that you see run in the background, and they are able to do all the kind of competition for you without you having any sort of knowledge about these different topics, or let's say having knowledge about how TensorFlow or how these machine learning models work. So I'll quickly just show you a demo of how you can actually just use on all of these online, right? So basically, like let's say we have an example of using let's say PoseNet. So a PoseNet is a very popular library that is basically detecting your entire pose of your body. So it is able to detect individual points of your body, let's say the different joints from starting from your head all the way to your toe. And let's say if you want to create an application that can detect, okay, if you're having a wrong posture, or let's say if you're having you're doing an exercise and if you're doing it correctly. So even that can be done by just detecting that particular action that you're performing. And the next thing that I wanted to talk about in this kind of a transfer learning is teachable machine. So basically, it's a tool that was provided by Google, and what it allows is that, as I've already said, that it runs these machine learning neural network based models that I showed in this neural network playground. And you really don't need to have any sort of knowledge of how these machine learning models work. So let's quickly get started with these. And now, as you can see, it basically provides you by default three different kinds of projects that you can start with. So it can provide you image based, image recognition based, audio recognition based, and even pose, which I just talked about. So let's say, for example, we take the image detection based model. So what you see over here, the different classes. So basically, in a machine learning, you can have multiple different sets of inputs or multiple inputs. So let's say you want to do a classification of different numbers or numbers from 1 to 9. So in that scenario, the different classes that you will be having will be each class will be pertaining to one different number. So a class can have multiple different input data set values, and these are pre-classified since we are using supervised learning. So supervised learning means that you already know the different kind of classes. And then what we'll be doing is that we'll be creating two different classes, and we'll see how our model is able to detect whether that particular like whatever image I'm showing to it is belonging to that particular class. So let's say that the first class name that we create is a mobile. So let's keep it in this way. Let's keep the second one to be a computer mouse, and let's keep the third one to be a water bottle. So now what you have to do is very simply, just you can upload your own images, or you can just add images from, like, you can hold your webcam and you can start recording. So let's say I start recording and I keep on adding new images, and the more number of images that you add, better would be the accuracy of the program. Because what happens is that in the machine learning program, when the machine learning model starts going through the input, it basically tries to extract the multiple different features from each and every different input data set that it gets. And the more number of images or the more number of data that you'll be working around with, the more number of features it will be able to extract. And based on those features, it will be able to classify different kind of objects in a better way. So let's take the example of the next part is, let's say we have a computer mouse. So again, we'll start and we'll click hold to record to basically record that many number of images as we had done. So we had taken about 50 images, so we can add more and more images. quickly. And let's say we now we take the third one, which is the water bottle, and we can select the water bottle and again start recording. And as you can see now, you can actually start to train your model. So what's happening again behind the scenes is that it is going to be using a neural network that is training the data that you're giving to it, and it is now training. And while it is training, we can go over the next few slides. So it's not just limited, to be honest, just for these kind of like examples or use cases. You can actually also use the transfer learning for much larger datasets. So one of the drawbacks of using this kind of a model is that the number of images or the number of data that you can actually work with is sort of limited to, let's say, about 10,000, 100,000 images. But let's say if you have much more images as compared to the limited amount, then you can use Cloud Auto ML that can allow you to train custom vision models with in much more capacity. So you can train up to 100,000 or even more than 1 million images at the same time. And that can directly then be deployed to TensorFlow.js. And this provides you the ability to train more than a million different images, and it's much more scalable as compared to using teachable machine. And this again provides you a great degree of accuracy with respect to the machine learning model, because you can again always tweak the model itself, and you don't have to create the model from scratch, because you simply just have to train your model based on the input data that is provided to you. And before going into the last topic of how you can actually use TensorFlow.js, we'll be covering on if our model has been trained. Okay, great. So our model is already trained, and if you actually look at the advanced over here, you can see the number of epochs, patch size, learning rate, and as I already said that all of these different things are again much more complex and again a bit out of the context of this particular topic. But again, so what's going on inside is that it's training a neural network, and if I click on under the hood, you can see that you can get to know a lot more information about your machine learning model that you have created. And let's say if I want to test it out, we had started off with three different classes as it shows. The first one being a mobile, the second being a computer mouse, and the third being a pod bottle. So let's say if I bring my mobile, and as you can see that it gives an almost accuracy of 100%, because it is able to understand the features of this particular device, and it is able to then whenever a new data set or a new input data comes into the picture, then it is able to understand those features, and based on the features that it has already been trained, and it will be able to predict. So let's say I bring the mouse, so it should be able to provide again, as you can see that it provides almost 100% output. And let's say if I finally bring the water bottle, we should be seeing, so as you can see it provides. And now the best part is that now you can directly just export this model. So let's say you wanted to make a very simple machine learning model that detects between a mobile, computer mouse, and a water bottle. You can just export this model for your application. Let's say if you're using JavaScript, it will basically even provide you the entire HTML code and the JavaScript code that you can directly just use. And you can export this, or you can download this model and directly just use it with your application. And it not only is limited to being used in TensorFlow.js, you can even actually get a TensorFlow based model. So let's say if you're writing a Python module, you can actually use it for even getting a Python based, or if you're using TensorFlow Lite, which is basically a TensorFlow model that has been sort of compacted to be used on mobile devices. So it provides you that much amount of sort of compatibility with even with the Android or let's say lower powered devices. So that is the power of teachable machine and how you can utilize it for creating your own web applications. And again, as I've already said, that it is not just limited to images. You can also train it with audio, with different kind of poses that I've already talked about with pose estimation, and more kind of models are being developed right now that are being provided by Google. So, so far we have covered two different types of models. One is the already pre-existing models that you can directly just import and start using. The second is transfer learning, where you're using the existing models to train them to become better understanding for your own custom data set or for your own custom application. And the third is, or the biggest, or what I can say is for enthusiasts to write your own code. So using TensorFlow.js, it provides you the ability to write your own custom machine learning models in JavaScript. Now, TensorFlow.js provides you two different types of APIs. So one is a high-level layers API that is similar to Keras. So in case you don't know about Keras, Keras is basically built on top of TensorFlow, and it provides you certain libraries and certain functions that make it a bit easier to work with TensorFlow, and it provides you some bindings that makes it a bit more easier and a bit more understandable for beginners who are starting with TensorFlow. But in case you want to go all out and write your models completely from scratch, it also provides you a lower level ops API, which allows you to write your own custom mathematical models, your mathematical functions. And this is probably the biggest enthusiast work that you can actually do with this low level ops API. And this diagram or this flowchart should give you a very good idea of how we actually use them. So at the top that you see is the models. So these are your pre-existing models that have been provided by TensorFlow.js that can be directly used. The higher level of that is the layers API, where you get these already built functions like your Keras model, similar to how Keras has been built on top of TensorFlow. And if you want to go all out and writing your completely custom code, you get the core or the ops API. And this API, from this using this API, you can actually write your own custom TensorFlow.js based code. And give me just once again. Yeah, so it basically you can write your own custom code completely from scratch with the core or the ops API. And now this ops API can help you write the code not only in not only in your client side but also server side. So one of the biggest advantages of TensorFlow.js is that it allows running the machine learning models on the client side as well. So now you don't need to create a separate server just for running a machine learning model. So earlier what used to happen was that you used to have your web application, and in case you wanted to have in case you wanted to have a machine learning based model, you had to write that code in Flask and then deploy that as a separate server on Flask or Django, and then connect it with a let's say with a Node.js based backend, and use that model for your web application. But now you can directly integrate it with your code without even having a server directly on the client side. And there are various advantages of running a machine learning model on the client side that we'll be touching upon a bit later. But it basically runs directly on the browser. And again, since today the browser is very optimized, and there are things like WebGL, WASM that provide you much more higher complexity based or much more higher computation based, graphic intensive based machine learning models that can be directly run on the client side without having a dedicated server. And one of the more important concepts that come into the picture is the TensorFlow Js Converter. So basically, this is a C++ library that has been written, and it's again completely open source, that allows you to convert any Python-based model into a JavaScript-based TensorFlow Js model that you can directly use. And again, TFJS converter is being actively used to convert a lot of different popular Python-based machine learning models to the TFJS models. And apart from the client side, you can also write the ops API, your own custom TensorFlow based TensorFlow.js based models on the server side as well, using Node.js, either like with the TensorFlow CPU or the TensorFlow GPU. And this slide sort of gives you an idea of how amazing is the performance of TensorFlow .js as compared to a TensorFlow. And as you can see, so one of the examples that it shows is the TensorFlow CUDA that runs on a Python-based embedding, running on a graphics card with a time of 7.98, while one is running on the backend on a Node.js based model using again CUDA, and it has very similar performance. And the next one also shows you how the CPU time is also quite similar in terms of the model inference, running on a model of the mobile net, which is again a very popular machine learning model. And so just to give sort of sort of this extension of what we are dealing with, so these you can actually just infer that how optimized TensorFlow.js is really. And now, sort of to give you a brief idea on how you can actually use TensorFlow.js on the client side, as I already said, and why it's beneficial to use it on the client side in the first place. So the first and the foremost thing is that it provides you much more privacy as compared to standard server side, because now what is happening is that whatever competition is happening locally on your browser. So you're not having some kind of a dedicated server where we are sending in your data. So you're having much more privacy as compared to a standard machine, as a standard template, or as let's say as a standard architecture, because whatever computations, whatever data that data flow is happening is staying locally inside your computer, running locally on your browser. And it provides much more lower latency because as I've already said that since now we're not dependent on a dedicated browser, so the communication that takes place between the browser and your data is now not dependent on a dedicated server. So it provides you much more lower latency in terms of the network response. And then you're also having much more lower cost, because again you're not having a dedicated server that you have to work with, and you're having much higher reachability and scaling as well, because again today browsers are becoming more and more optimized. So scaling up the browsers and scaling up the use case again is quite amazing when it comes to the client side render. And but that doesn't mean that the server side dependency are not there. You can run much more complex models on TensorFlow Node.js based backends, which cannot be run simply on the client side if you're running very large models. And then you can use the TensorFlow save model that comes from the TensorFlow.js without actually converting it, and you can write your custom machine learning based models with again directly using the ops API on the backend. Then you just have to code in one language, that is again JavaScript, and you also get a much more larger support of the npm packages. So all of us who are Node.js developers must be knowing that how amazing is to be able to use any kind of a package from npm to make our Node.js based code much more easier to perform. And it also, a Node.js being a just-in-time compiler, it provides a much higher degree of performance, because it is able to process things very fast and very quickly. So it also is again amazingly fast as compared to a client-side rendering for running your machine learning models. And to get more information, you can go to tensorflow.org/js to get to to get started by with understanding of tensorflow.js. And you can, as I already said, that some of the custom built models that are already there, you can go to tensorflow.org/js/models, where you can find all the different kind of pre-built models that have been created. Then you can also find the completely open source code on github.com/tensorflow/js. So there is slash tensorflow/tf.js. So this shows you the completely open source code for TensorFlow JS. As a policy, that it's a completely open source library that allows you to run machine learning models on the web. And again, it's completely open source and free, right? So that should give you an idea on the TensorFlow.js. And finally, you can also join in the Google group at tensorflow.tfjs@tensorflow.org to get more information, and to get regular updates, and be a part of this community where they're discussing about the applications and the use cases of tensorflow.js. And before coming on to the actual part, I would like to take up the questions first. So the first question were, what are tensors? So as what I've already covered in the slides is that basically the main reason why TensorFlow was made was to sort of deal with very large, complicated mathematical operations. And tensor is nothing but, it is, you can consider it to be like an array which has multiple different dimensions. And when we say dimension, it says that it can be like a 2D matrix, it can be a 3D, it can be n by n cross n matrix that you have. And it basically has all of these different numerical numbers that are representing the input data that you're having, and whatever operations that take place are taking place on these tensors. So whether it's like a transformation operation, whether it's just a simple summation operation, are taking place on these large mathematical arrays that are being used for very high level competitions, numerical competitions that take place. And the way the information sort of flows from one tensor to another is by the use of the data flow graphs that are connecting the different kind of nodes that are again the tensors, and how they're interacting with each other. So let's see if we have any other questions. Again, in case you have any other questions, please just ask them over here. And in the meanwhile, we can also have a session where I'll be just sort of showing you a quick demo on how easy it is to actually deploy a TensorFlow JS based application and start using TensorFlow.js application without really knowing anything much in detail. So uh, quickly, if in case anyone has any questions, we can quickly just then go through a simple application that you can actually create by knowing just the basics of HTML and CSS and JavaScript, and without knowing any prerequisite knowledge about TensorFlow. So just to sort of give you an idea, I had already created an application, and just for the time purposes, I had created this application which I can quickly just show to you. And let me again quickly showcase my so let me just share my screen. So this was the application that I had created. Basically, it's called an ML5 based mood detector, or basically changing your mood. So what you do is that you give the ability for the uh, web browser to detect your face. So let me just refresh this. And this was a demo application that I created. Again, as you can see, now I have started off my camera feed. And as you saw with the variable, with the teachable machine, what you have to simply do is train a number of images with a happy face, and train a number of images with a sad face. So let's first do it with a happy face. Okay, so I guess 21 images are good enough, and let's train one with a sad face or a neutral face. So let's say we have trained an equal number of images. Now we just have to simply train. So again, as we had with the TensorFlow teachable machine, this basically takes in two different classes. One is of happy images and one is of sad. So let's say if I make a happy face now, so it changes the background. And let's say if I make a sad face now, so basically what's happening is that based on your mood, it is able to change the background and the sound of your web page. So again, if I make a happy face, and if I make a sad face, it will show the raindrops. So as you can see that it is able to detect the incoming feed So once it has trained the model to detect whether it's a happy face or a sad face, it will basically now take in the new input data, that whatever data you provide to it. So let's, as you can see, like it is changing it based. And again, to make the model more and more accurate, you'll have to provide more and more input data to it. And just to sort of quickly go through the code base, as you can see, this is like the sketch.js that is part of the model. So what we have done is that we have used MobileNet. So MobileNet is again a model that can be used, and what we have used is basically ML5. So just to sort of give you an idea about ML5, we have talked about TensorFlow.js as being an easy way for like using TensorFlow and using machine learning for your web-based applications. Now, ML5 goes up one step ahead and makes it even easier for you to use TensorFlow.js in your application by creating. So it sort of acts like Keras acts on TensorFlow. So ML5 has already some pre-built classes that you can directly just use, that also make it much more easier to understand the machine learning models. And this has exclusively been made to be approachable by the large number of students who might be just getting started with TensorFlow or TensorFlow.js, or for creative coders or artists who might not be having a lot of knowledge about mathematics or on machine learning in general. So basically, this library provides you access to machine learning models that can be run on top of TensorFlow.js, and it provides you very simple to use uh, models and functions. So as you can see from the code, what we have done over here is that we have basically used the ML5 feature extractor, which is basically a function that allows you to extract any particular machine learning model that are already there. So over here we are using MobileNet, which is again a very popular machine learning model that has been created for detecting images, for image classification, that runs like it basically runs the neural networks in the background. So you can simply just call, or you can load up a machine learning model, and then what we're doing is that we are basically running a classification algorithm with this MobileNet, as already said. So basically, the classifier is now taking in the input video feed that you get from your camera. And let's say we are having two different kinds of inputs or classes. So the first class is the stat class. So the more number of images that you add to it, the number of times you click, basically it's continuously adding that particular image or that particular data to the classifier for that particular class. So when we're talking about the stat class, the more number of images that you add to it, those get added to the classifier, and we are just adding it to the classifier. So basically, that is your input data set that it is working on. Similarly, for the happy, you simply, the more number of images that you add and more number of images that you add, those are going into the classifier and getting added to the happy class. And once you click on train, so basically it will take in all the different input data set that it gets for both for the happy class and the sad class, and it will extract the features that a machine learning model does. And you simply just have to use the model dot train. Now, normally, if you were writing a custom MobileNet based model, it would have taken more than at least more than 150 lines to actually get till the training step. While over here, you simply just use the dot train function to actually just train your setup. So once you've already trained, then you can start getting your results. And again, so now whatever input stream that you're having within the webcam, the classifier will now detect that particular frame, because again it's working frame by frame, and within that frame it will try to understand, okay, whether your expression lies under the sad category of classes or within the happy class. And if so basically, as you can see, the classify. So this classify function is again similar to a predict function. So once, let's say, you have trained a machine learning model, you can use dot predict to predict the results. And over here, we are just using this dot classify to classify the results that we're now getting. And in case like this is sad, we simply just change the background image to have rain, and let's say if it's a happy image, we basically put up a mountainous background. So it's very simple to use this case, and as you can see, like, it's not even 100-line code, and you have just created a mood detecting mood changer, like background changer using mood detection. And it's just a 50 to 90 line number of codes. Again, just having very brief information or understanding of JavaScript can help you create these amazing models and these amazing applications that you don't even require complete knowledge about machine learning. So this was basically regarding the TensorFlow.js, and this should give you an idea of how we're using TensorFlow.js for creating these amazing machine learning based applications, and creating very easy to use machine learning applications without having much knowledge about them, and directly using them for your applications, for whatever web based applications that you might have. Just to again summarize, you can have three different types of uh, embeddings. So one is using custom models, like I just used the mobile net model that has been custom built, and you can directly just use their functions like classify, training, and then you can train the existing models, like the transfer learning, where as showed you on the teachable machine. And finally, you can also use things like writing your own custom code by using the ops or the layers API. So that sort of then brings to the end of this particular session, and I'll quickly just go over to the slide, and again sort of summarize. You can again connect with me on these links on Twitter at How Develop and LinkedIn at Shivay Lamba. So this sort of brings us to the end of the presentation. Again, in case you have any particular questions, please just ask them in the comment section, and I'll be more than happy to take them up. In case anyone has any specific questions, please make sure to ask them in the comment section. So one of the questions that we had got was about tensors, and I'll be more than happy to take up any of the other questions. Again, big thanks to the entire team at DSC GTBIT for providing the platform for sharing about TensorFlow.js. Again, since I've already said that it's completely open source, so you can get started by building amazing machine learning models and machine learning based applications on the web by using TensorFlow.js. And again, you can contribute to the TensorFlow.js repository on GitHub. Again, it's completely open sourced, and TensorFlow itself has a Google Summer of Code program that it runs. So in case if anyone is interested for TensorFlow as an organization, you can look to contribute to it, and it has a lot of different projects that are part of the Google Summer of Code for TensorFlow. So again, a big thanks, and probably we can conclude now.